One of the major topics in this chapter has been how to write a linear equation, how to create a linear equation to fit some parameters. And so now you've learned a lot of different ways to write these equations and a lot of different information about a single equation. And now I'm starting to mix them up on you. I'm starting to give you different pieces of information and asking you to convert that into a line. So what I'm going to do here is some examples of different scenarios, different types of problems that you might run into. But first, let's review the different forms of a linear equation. The most direct one is this one, y equals mx plus b. Okay, and that is slope-intercept form. Slope-intercept, which means to write an equation in that form, you need a slope and you need a y-intercept. Okay? There's also point-slope form, which looks like this. Y minus y1 equals m times x minus x1. And this is convenient if you don't have the slope and the y-intercept. Well, you'll still need the slope, but you can do this with the slope. Oops. You can do this with any point on the line and the slope. But the problem is you don't want to leave your equation in this form. So you can use this more often because it works with any point, not just the y-intercept, but any point. But after you write it that way, you're always going to want to convert it back to this slope-intercept form. Okay, so when you're looking at one of these situations, the first thing you want to ask yourself is, do I have enough information to go straight for this? Because if you do, that's the most direct way to do it. If not, let's think about how we could get it into this form. And then some of the other things you'll run into, for example, are your horizontal and vertical lines. A horizontal line has a slope of 0, and it's always going to be just y equals some number. And a vertical line is going to have a slope that's undefined and is always going to be x equals a number. So sometimes these weird ones pop up too. Okay, so let's look at our first situation. Possibly the most direct type of problem I can give you is one where I hand you the slope and the y-intercept, because those are the two pieces of information you need to go straight to slope-intercept form. So if I hand you the slope and hand you the y-intercept, all you really need to be able to do is plug it into this form. Y equals mx plus b. Remember, the 5 is your m and the 2 is your b. So your equation would end up looking like this. Y equals 5x plus 2. Very straightforward. This one's almost as direct as the last one. If I give you a y-intercept and then I hand you the line that it's parallel to, that's almost as good as me just handing you the slope and the y-intercept. Because you have the y-intercept, and the parallel line is going to have the exact same slope as the line you're going to be writing. So all we need to do is pull the slope out of this equation. So we have our y-intercept here. That's going to be our b for our slope-intercept form. And then from our parallel line equation, we need to take the slope out. Now, if this were in slope-intercept form, I would just pull the m. I would just pull the number that's right in front of the x. This is in standard form, which does complicate it a little bit. This is where we're going to use that trick, m equals negative a over b. So this, let's see, a would be 3, so I'm going to make that a negative 3, over b would be 2. So my slope here is negative 3/2. Okay, that's my m. And so when I go to fill it into slope-intercept form, y equals mx plus b, I've got my m, I've got my b, and my equation would look like this. Y equals negative 3/2 x plus 5. Okay. Almost as straightforward as that would be if I were to hand you a line that's perpendicular plus the y-intercept. So again, just like before, I'm handing you a y-intercept. This time I'm just giving you a line that's perpendicular instead of a line that's parallel. So again, I'm handing you a y-intercept, and I'm giving you the line that it's perpendicular to. So this is my b, and I'm going to pull my slope from this perpendicular line. My slope's going to come out of there. Now, this one is in slope-intercept form, so I can find the slope a little easier. The slope is just that 4. But remember, when it's perpendicular, you need to take the opposite reciprocal. So 4 would become -4, and then it would flip over and become -1/4, and that's going to be my m value. So now I have my m and my b. Oops. And my final equation, I'm just going to jump right to it, would look like this. Y equals -1/4 x minus 3. So again, almost as good as just handing you the slope. You just have to remember to do this step here. Okay, next step would be a line that has either a 0 slope or an undefined slope. That's what these are saying, plus a coordinate that it goes through. So if you look at this, this actually looks like you could use point-slope form because you're given a point and you're given a slope. And you could. That's sort of the long way around, but it would get you to the right answer. But if you recognize this situation, a slope of 0, as having to be a y equals a number equation, because it's going to have to be a horizontal line, then you just have to look up at your coordinate and say, what's my y value up here? So this one is going to have an equation that's just y equals 9, because 9 is my y coordinate. This here is actually the same kind of question as this is. It doesn't specify that it has a slope of 0, but it tells you that you need a horizontal line. And again, a horizontal line is going to be y equals some number. Okay, so again, from this, I know that it's going to be y equals a number. And then I look up here in my coordinate, I see what y is equal to, and I say my final equation would be y equals -3. Okay, so really this is two different ways to ask the exact same question. Okay, let's try one of these with an undefined slope. So notice this is really the same kind of question that we were dealing with up here, except this time I'm telling you that it's an undefined slope. Well, if it's an undefined slope, that's going to be a vertical line, so that's going to be x equals some number. So it would really do you well to know this, that slope of 0 is y equals a number, undefined slope is x equals a number. And so again, I'm just going to say if x has to equal a number, what should x equal? It has to equal 6. So my final equation would just be x is equal to 6. Okay. Similarly, I'm not going to do this as an example, but I could also ask you the question, I want a vertical line through a coordinate, and then it would still just be x equals that number. Okay. So let's suppose I give you the slope and the coordinate of one point on the line, but not the y-intercept. So before we were able to just jump straight to slope-intercept form. Now I have the slope and a point. Slope and a point. So that means I'm going to have to use point-slope form, which looks like this. Y minus y1 equals m times x minus x1. The good news is what I've given you here is pretty straightforward. Okay, I've given you the m, which goes here, and then I've given you the x1 and the y1. So let's plug those numbers in. I'm going to do y minus my y1. X1 and y1 are my coordinates, the numbers in my coordinate. And remember, the second one is my y. So I'm really doing y minus -2. Those two negatives are going to join together and make a positive. So that's really going to be y plus 2 equals m, which is 1/5, x minus 10. Okay. Now I need to simplify this and make it look like slope-intercept form, so I'm going to start by distributing the 1/5. I get y plus 2 equals 1/5 x, and then 1/5 times 10 is 2, so that would be 1/5 x minus 2. And then I want y by itself, so I'm going to subtract 2 from each side. And as a final answer, I get y equals 1/5 x. Careful here, that's minus 2 or that's like -2 minus 2, which is really -4. A lot of people are going to think that just cancels out. Okay, so there's an example of one where I was given the slope and a coordinate. So let's suppose I give you a y-intercept and another point on the line. So this time you're missing the slope, and you need the slope no matter which form you're working in. Well, remember, the y-intercept is really just a point on the line. It's a special point. It's where the line crosses the y-axis, but it is just a point on the line. So really that y-intercept I could write as a coordinate. And if it's the y-intercept, that means I want the number in the y spot and I want a 0 in the other spot. So now I've got two coordinates on the line, 0, 2, and 3, 4, and I can use the two coordinates to find the slope. So I can say m equals y2 minus y1 over x2 minus x1. And so let's see, I'm going to call the 0, 2, I'm going to call that my coordinate number 1. So this would be x1 and y1, and this would be x2 and y2. So when I go to plug into this formula, y2 is 4, y1 is 2, x2 is 3, and x1 is 0. That's going to give me 2 over 3 as my slope. Now, I have my slope, my 2/3, and I have my y-intercept. So now I can jump straight to slope-intercept form, which is the most direct way to go. Okay. In this form, here's my m value. Whoops, lost my pen. M is my 2/3, and my y-intercept, that's my b value. So my equation would end up looking like this. Y equals 2/3 x plus 2. And that's my equation. So this is sort of similar to the last one. What if I just give you two coordinates? So now you don't have a slope or a y-intercept. So we definitely can't jump straight to slope-intercept form. But if you have two coordinates, you can find the slope by saying m is going to be equal to y2 minus y1 over x2 minus x1. So, let's see, this would be x1 y1 and x2 y2. So y2 minus y1, that would be 7 minus 4 over -5 minus -6 is really going to be -5 plus 6. That's going to give me 3 over 1, which is really just 3. So my slope now is 3, but I'm still missing a y-intercept. But I do have the slope and a point. Actually, I have 2 points. I could choose from either one. That means I'm going to go with point-slope form. Okay, so I'm going to choose, and remember in these situations you get to choose which coordinate you're going to use. I need my m to be 3, and then I'm going to use the -6, 4, which means for now I'm ignoring this other coordinate. Okay, I really only needed that to be able to find my slope. So my y1 would be 4 from up above, so y minus 4 equals 3 times x minus -6 is really going to be x plus 6. Let's distribute this 3. So I get y minus 4 equals 3x plus 18. And then I'm going to move that 4 to the other side. I'm running a little short on space here, but it would end up being y equals, let's see, 3x plus 22. Here's my final equation for that one. I could also give you a problem where I just hand you the two intercepts, the x-intercept and the y-intercept, which, again, you don't have your slope. That's a problem. We'll have to find it. But remember that the intercepts are both really just coordinates. So I could take the x-intercept and rewrite it as the coordinate 4, 0, and the y-intercept and rewrite it as the coordinate 0, negative 8. And notice that in the x-intercept, I made sure the number went in the x spot, and in the y-intercept, I made sure the number went in the y spot. And now I can treat this almost like I treated that last one. I'm going to first find my slope. So I'm going to do y2 minus y1 over x2 minus x1. So y2 would be negative 8 minus y1, which is 0. x2 is 0 minus x1, which is 4. That's going to give me negative 8 over negative 4, which means my slope is 2. Now the good news is, now I have my slope and I have my y-intercept up here. So I could use point-slope form here if I wanted to, or I could just take a shortcut and go straight for slope-intercept form. Y equals mx plus b. Here's my m, here's my b. So y equals 2x minus 8 would be my formula there. Okay, this one looks like it's simpler than it really is. Because you see slope, you see intercept, and you think I can just plug that straight into y equals mx plus b. The problem is this time you're given the x-intercept and not the y. So you don't have a b value. You can't just plug this straight into slope-intercept form. Again, just to reiterate, you cannot use mx plus b here. You can't because you don't have a b value. Okay? So what we have to do is we have to treat this x-intercept like it's a coordinate, which would be negative 6, 0. And then I have a point and a slope, so I can go into point-slope form. Y minus y1 equals m times x minus x1. So y minus, my y1 would be the 0, so y minus 0 equals m, which is 1/3, x minus x1, so minus negative 6 is the same as plus 6. Let's distribute this 1/3. The good news about this one is y minus 0 is just y, so you kind of save yourself a step there at the end. So y equals 1/3 x, and then 1/3 times 6 gives me 2. So y equals 1/3 x plus 2. But you have to start in that point slope form. You can't just go straight to slope intercept when you're given an x-intercept. Similar to that last one would be if I were to hand you an x-intercept and a line that's parallel. Which remember, I'm handing you an x-intercept just like I did before, so you're going to have to treat it like a coordinate. And I'm handing you a parallel line. Well, a parallel line, you can just take the slope right out of it. So let's make one up here. Let's suppose I gave you this, an x-intercept of 5 and parallel to the line 4x minus 5y equals 8. Well, again, that x-intercept, because it's not a y-intercept, you're going to have to treat this as a coordinate. You're going to have to treat it as 5, 0. And then we're going to need to take our slope out of this line. And remember, this is in standard form. So I'm going to say m is negative a over b, which means it's going to be negative a is 4, so negative 4, over b, which is negative 5. Don't forget that negative is attached to it. And negative 4 over negative 5 is really just equivalent to 4/5. So then, when I go to write it in point-slope form, I'm going to start with this. Remember, my m is over here, the 4/5 that I came up with, and my x1 and y1 are the 5 and the 0. So y minus y1, which is 0, equals 4/5 x minus x1, which is 5. Again, y minus 0 is just equal to y. This would become 4/5 x. And then 4/5 times negative 5 comes out to be negative 4. So your equation would be y equals 4/5 x minus 4. One last scenario that I came up with. I could give you a coordinate, a point, and a perpendicular line. So here's my point. It's perpendicular to this line. So I don't have a y-intercept, which means I can't go straight for slope-intercept form. Again, I'm going to have to go with point-slope. I have my point. That means I just have to take my slope out of this line. Well, the slope right now is negative 2/3. That's my m. But perpendicular means I need to take the opposite reciprocal. So I'm going to turn it to positive 2/3 and then flip it over and make it 3/2. That's now my m. Here's my x1 and y1. So I'm going to go straight for y minus y1 equals m times x minus x1. So y minus 7 equals m, which is 3/2, x minus x1, which is 12. Let's distribute that 3/2. So y minus 7 equals 3/2 x, and 3/2 times 12 is going to be 18. And then I'm going to add 7 to each side. So I end up with y equals 3/2 x minus 11. And that's it for that one.